All right, welcome back to this channel, and we are going to be solving questions on variation. Remember, we talked about variation the last time, and we said we talked about the two basic types of variation and some other the other two types that are derived from those two types of variation. So we talked about the direct variation, the indirect or inverse variation. Then we talked about the joint and the partial variation. So in this video, we are going to be doing some questions on both direct variation and indirect variation. So we talked about direct variation as a variation where the two variables are going to, the same thing is going to happen to them such that if one increases, it causes the other to increase. So if one decreases, it causes the other to decrease. That is a direct variation. They go in the same direction. While in inverse variation, they go in inverse directions. So for this one, it's a direct variation question. It says if P varies directly as R and P is equal to 10 when R is equal to 6, find the relationship between P and R. Hence, find R when P is equal to 12.5. So now let's solve this question. It's a very simple question. It says, now we're going to solve it just as we are reading. If P varies directly as R, we write that this way, that P varies directly as R. Now this is not yet an equation, so we're going to make it into an equation. And how do we make it into an equation? Remember I said the last time that there is, before this relationship can actually exist, there is something that is constant. There is something that is constant. So, and that is the K. So P will now be equal to KR. So it is the presence of this K that this relationship is occurring. That is, P is very directly as R because of this constant. So these are equation now. So we now impute the values of 10 and the value of 10 and the value of R given. So we have the value of P rather. So we have 10 is equal to K by 6. So K will now be equal to divide both sides by 6. You have 10 over 6. So you have 2 here, 5, 2 here, 3. So that K is equal to 5 over 3. You can leave your answer this way. So now the next thing you want to do is, it says, find the relationship between P and R. Now listen to me. Whether you are told to do that or not, always write the relationship between the variables. So let's write the relationship between the variables from this equation. So what we'll simply do is substitute this guy in the value into this equation so that we have P will now be equal to 5 over 3R. Now, so this is the relationship between the two variables. So the reason why I'm doing this is because this 5 over 3 is never changing, but the P and R are the variables. They are always changing. Remember I said variables means changing. Okay, so the next thing we'll now do is we'll find R when P equals 12.5. So we're told to find R when P equals 12.5. So using that equation now, P equal to 5 over 3R. So that's the essence of writing it. So R is what we're looking for. P is this. So we have 12.5 is equal to 5 over 3 times R. So we can cross multiply here. So by cross multiplying, we're going to have 5R is equal to 3 by 12.5. So from here we can divide both sides by 5. So if we divide both sides, let's divide, here we cross multiplied, divide through by 5. So divide both sides by 5 and over 5 here. So if 5 goes through here, 1, 1, 5 here, 1, 5 in 12, 2 point here. It's going to bring 2 in 25. It's going to be 5. So we have R is equal to 3 by that is 7.5. And that is the answer. Alright, look at the second question. It says if Y varies as square root of M. So this a direct variation, whether it is, since it didn't say inversely or whatever, since it just says y varies as this, then we know it is a direct variation. So solution, we have y varies directly as square root of n, the same way. So we are going to go on to say y is equal to k square root of m, k times square root of m. So this is the equation. Now it now says, and y equals 9. So we have to solve for this constant. Y is 9, m is 9. So y is 9 equal to k root 9. So we divide both sides by root 9. But before that, we can simply take root 9. So 9 will be equal to k times 3, that's 3k. So we have divide both sides by 3 now. So k will be equal to 3. Then we can now substitute it into this equation so that we have y equal to 3 square root of 3 root n. And that is the equation connecting y and n. So we can now solve further. It says we should find y when n equals that. So y when n equals 1 over 7 over 9, which is 16 over 9. That's 16 over 9. So you have y, which is already the subject of the formula, equals 3 times square root of 16 over 9. So you have y equal to 3 times 4, the square root of 16. So we can take the square root separately. Square root of 16 over square root of 9. So y will now be equal to 3 times the square root of 16 is 4, and square root of 9 is 3. So 3 can take care of 3, so that y will be equal to 4. And that is the final answer. Now this is another question, the third question. It says, given that n varies inversely as d cube, and that n is equal to 240 when d equals 3, find n when d is 2. Now this is also a very simple question, and what we have to do is write as it is written, as we read it, given that n varies inversely. So now n varies inversely as d cubed, so we have 1 over d cubed. This is an inverse variation. So the same way we introduce constant, so we have n will be equal to k times 1 over d cubed, which will be n equal to k over d cubed. So this is like our formula now. Then we can now begin to slot in our values. It says that n is 240, so we have 240 is equal to k, which is, we have to first solve for the value of k, of course, over d cubed. D is 3, so 3 times 3 raised to power 3. So we now have, we'll cross multiply here, so that we have k equal to 240 times 3 cubed. 3 cubed is 27, so 240 times 27, and k will be equal to, okay, this is quite some large number. What we can do is we can use this value for our k, so that k, so we are asked to find n now. Find n when d equals 2. Remember that n will now be, so our equation is going to be n equal to 240 by 227 over d cubed. So this is what we're using now. Then we are looking for n, which will be equal to 240 now times 27 over d cubed. That's 2 cubed, 2 raised to power 3. So we have n will be equal to 240 times 27 all over 2 cubed is 8. So 2 here, or 8 here 1, 8 here 3, 0. So n will now be equal to 270 times 3, and that is 810. And that is our answer. So this question says, if x varies directly as y, z raised to the power 1 over 3, and y varies directly as z raised to the power minus 2, show that x varies directly as y raised to the power 5 over 3, 5 over 6. Since our point of focus is this, x varies directly as y raised to the power 5 over 6, what we simply have to do is look for a way to turn this whole expression into x and y alone. So from here, it says that y varies z to the power minus 2, meaning that y will vary directly inversely as z squared. That is what it means here. And it means that it will be equal to y varies directly as, so if we introduce the constant here, we're going to have y will be equal to k over z squared, which means that if we cross multiply, we're going to have z squared equal to k over y, and we can take square root of both sides here. So if we take square root of both sides here, this is what we're going to have. So that we say z will be equal to the square root of k over y. Hence, we can introduce this into the equation. So the constant, if we remove the constant, then what we have will be z will be equal to 1 over square root of y, which means that z will be equal to 1 over y raised to the power 1 over 2. So we can now impute this into this equation, this one on top. So recall now that x varies directly as yz raised to the power 1 over 3. So and z is equal to 1 raised to the power 1, z is equal to 1 over y raised to the power 1 over 2. So we can impute this. Substitute 1 over y raised to the power 1 over 2 into this. So we have x varies directly as y now. Since z is this, we now have 1 over y raised to the power 1 over 2, all raised to the power of 1 over 3. So in essence, we can now have that x will vary directly as y multiplied by, we can bring this up so that y will be equal to y raised to the power 1 over 2 minus 1 over 2, all raised to the power 1 over 3 in this way. So here we're going to have x varies directly as y, and y, now this, we are going to take the product of 1 over 2 and 1 over 3 here, so we're going to have negative 1 over 6, negative 1 over 6. So now we are going to combine this, because this one is raised to the power 1, so we now have x varies directly as y raised to the power 1. This product, you remember law of indices, that if we have a raised to the power m times a raised to the power n, we're going to have a raised to the power m plus n. So the same way here, we're going to say plus minus 1 over 6. So we now have x to vary directly as y, 1 over 1 minus, plus times minus, is going to be minus 1 over 6. And you have x to vary directly as y raised to the power LCM of 6 and 1 is 6. 1 is 6, 6 by 1. We're going to have 6 minus 6 and 6, 1 by 1, that is 1. So you can therefore have it that x varies directly as y raised to the power 5 over 6, and that is what we have there. Yes, so that is basically how to prove it. And that brings us to the end of the calculation on direct variation, indirect, and joint variation. So in the next series of videos, we're going to do a lot of questions, at least some number of questions on partial variation. Please do also subscribe to this channel, as we are going to be doing a lot of mathematics stuff and breaking down mathematics in the easiest way possible for you. Thank you very much.